Part 2 of projectile motion. Let us discuss types of projections. There are two types of projections. These are horizontal projection and oblique projection. Horizontal projection. An object thrown horizontally with an initial velocity u from a certain height is called horizontal projectile. Any object that is thrown horizontally from a certain height is considered to be horizontal projectile. The horizontal and vertical motions of a horizontal projectile are treated as follows. Because horizontal projectile is a two-dimensional motion. Horizontal projection is two-dimensional, means it has horizontal motion and vertical motion. We have seen that horizontal motion of a projectile is uniform motion. Uniform motion means speed is constant. So the initial speed ux and vx are the same, which is equal to u. Because ax, acceleration in the x direction, is 0. Why is acceleration in the x direction 0? Because there is no force which is acting on the projectile in the horizontal direction. The air resistance is neglected. And when we come to x, the horizontal distance, it is ux times t or vx times t or ut, because ux and vx are equal. We have derived it from average velocity. Average velocity is equal to distance over time. The average velocity and instantaneous velocities are equal, so ux and vx are equal. The range or the maximum horizontal displacement is ux times total time, or vx times total time, or u times total time. This is the horizontal motion of a projectile, which is uniform motion. These are equations. When it comes to vertical motion, it is uniformly accelerated motion. Acceleration is constant. Acceleration is uniform. Vy is gt. It is uniformly accelerated motion and similar to that of downward through, which is gt. Why? Because ui is 0. Because the object is initially thrown horizontally, and the vertical acceleration is equal to acceleration to gravity, or 9.8 meters per second square. And the velocity, the vertical velocity is v squared is equal to 2gy. Do you know why? Vy squared is equal to ui squared plus vy squared is equal to ui squared plus 2gy, but ui is 0, and hence ui squared is 2gy. Why vertical displacement at every time is given by 1 over 2gt squared? Because ui is 0, and hence t is at any time is given by square root of 2y over g. And the height in which the projectile is thrown is 1 over 2g times total time squared. This implies that total time is square root of 2h over g. By the way, these equations are similar to that of freely falling body released from rest, because ui is 0. It is uniform accelerated motion because acceleration to gravity, and it is constant. The total time of flight does not depend upon the velocity of the projection. It depends upon the height of the building from which it was thrown. Range is the horizontal distance between release and landing points. It is the horizontal distance between. One to the symbols ux, vx, u, ax, x, r, t, capital T, ui, vy, vy, and h represent in the above equations. Ux stands for initial velocity in the x direction. Vx stands for final velocity in the x direction. U stands for the resultant initial velocity. Ax stands for acceleration in the x direction. X stands for the horizontal distance. R stands for the range, or the maximum horizontal displacement. T stands for time. Capital T stands for total time of flight. Ui stands for initial velocity in the y direction. Vy stands for vertical velocity in the y direction. V stands for resultant final velocity. Y stands for the vertical displacement at any time t, and h stands for the height from which the object is thrown. Both distance and time are measured from the origin xy. Look, 0, 0. Look, This object is thrown horizontally. The initial velocity is only ux. We have no initial velocity in the y direction because it is originally thrown horizontally. Thus, y is positive in the downward direction because it is the origin. Vertical displacement and horizontal displacement are measured from this origin, and his vertical displacement is taken to be positive when the projectile or the object moves downward by the action of gravity. The projectile follows a semi-parabolic path. This is the trajectory of the horizontal projection. Do you know why the projectile is following this semi-parabolic trajectory? Because gravity or gravitational force pulls the object downward. The velocity of the horizontal projectile at any time is given by v squared vx squared plus y squared. Always, this velocity, this resultant velocity can be resolved into x component and y component velocities. That is why the projectile is said to be two-dimensional. The velocity can be expressed in horizontal velocity and vertical velocity. This velocity is the sum of Vx and Vy, and its magnitude can be taken by using Pythagoras Theorem because they form an angle of 90 degrees. The touchdown velocity of the projectile then becomes, meaning the velocity of the projectile when it strikes the ground, v squared vx squared plus y squared, but Vx is u squared because Vx is equal to ux in case of horizontal projection, and Vy squared is 2gh. The direction of the resultant velocity is found from tan theta opposite Vy over adjacent Vx, which implies that theta is time inverse of Vy over Vx, where theta is the angle that V makes with Vx. Let us see example for horizontal projection. A ball is thrown horizontally with a velocity of 10 meters per second from a 45 meter tall building as shown in the figure below. Calculate the horizontal displacement x, vertical displacement y, horizontal velocity vx, vertical velocity vy, and the resultant velocity v of the ball after 1 second, 2 seconds, and 3 seconds. This is the figure. The object is the ball is thrown horizontally with an initial velocity from a 45 meter tall building, and we are asked to calculate different quantities, and the quantities to be calculated are x, y, vx, vy, and v for times 1 second, 2 seconds, and 3 seconds. Time in second, 0, 1, 2, and 3 is given. Then let us calculate x first. X is ux times t, or ux is 10 because the initial velocity horizontal is 10, means it is only ux. Uy is 0. 10 times 0, 0. 10 times 1, 10. 10 times 2, 20. 10 times 3, 30. Y, 1 over 2gt squared. It is in formula state motion. 1 over 2g means 5t squared. 5 times 0 squared, 0. 5 times 1 squared, 5. 5 times 2 squared, 20. 5 times 3 squared, 45 meter. Vx is equal to ux, which is 10, meaning it is constant. 10, 10, 10, 10. That is why we say the horizontal motion of a projectile is uniform motion. Vy is gt, which is 10 times t, because uy is 0. It is 0, really. 10 times 0 is 0, meaning the initial velocity is 0. After 1 second, it has a velocity of 10. After 2 seconds, it has a velocity of 20. And 3 seconds, 30. The velocity, the horizontal velocity is constant. The acceleration, the horizontal acceleration is 0. The vertical velocity increases at constant rate. Look, 0, 10, it increases by 10, 10 to 20, increases by 10, 20 to 30, increases by 10. This indicates that the acceleration is 10. The resultant velocity is square root of x square plus y square with Pythagoras theorem. It is 10 square 100 plus 0 square 0. 100 when it is taken out of square root, it becomes 10. 10 square 100 plus 10 square 100. The sum of the two is 200. When 200 is taken out of square root, 10 radical 2 and so on. These are the values. In figure, we can see the above example properly. The origin is 0, 0, meaning x is 0 and y is 0. If there were no gravity, the path which would be followed by the ball or the projectile was this straight line. Because of the presence of gravity, the ball moves downward at a constant rate, and hence the path becomes semi-parabolic, or the trajectory is semi-parabolic. Look, let us see the horizontal motion. At 0, x is 0. After 1 second, x is 10 meters. It has moved a distance of 10 meters. After 2 seconds, it has moved a distance of 20 meters. And after 3 seconds, it has moved a distance of 30 meters. Look, in 1 second, 10 meters. In 2 seconds, 20 meters. In 3 seconds, 30 meters. That is why we say the motion is uniform. Equal distance is covered within equal interval of time. From 0 to 1 is 1 second, it has moved 10 meters. 1 to 2 is 1 second, it has moved 20 meters, meaning the gap is 10 meters. And from 2 to 3 is 10 meters, and hence it is 30 meters. When we see the vertical motion, it has moved a distance of 5 meters within 1 second. Look, 5 meters within 1 second. 10 meters within 2 seconds. 45 meters within 3 seconds. So, the position of an object at any time t can be given by position 1 is 10, 5. It represents it has moved a distance of 10 meters horizontally and 5 meters vertically down. P2, 20, 20. Horizontally, it has moved 20 meters horizontally and it has moved 20 meters downward. P3, 30, 45. It has moved 30 meters horizontally and 45 meters downward. This is all about horizontal projection. It is two-dimensional motion because it has horizontal and vertical positions at any time, and also horizontal and vertical velocities at any time. The other type of projection is oblique projection. We have said that there are two types of projections. These are horizontal projection and oblique projection. And oblique projection or projectile at an angle is an object thrown into space at some angle theta to the horizontal or vertical. An object thrown at an angle into space is considered to be oblique projectile. It is thrown neither vertically upward or downward nor horizontally. Instead, it is thrown at an angle. Look, this is horizontal oblique projectile because it is thrown at an angle theta to the horizontal. Consider a projectile thrown with an initial velocity u by making an angle theta with the horizontal as shown in the figure below. This is the release point. This initial velocity makes an angle theta with the horizontal, and hence it can be resolved into ux and uy. This is the initial velocity in the y direction is upward, and in the horizontal direction is to the right. The velocity of the object at any point has two components, Vy and Vx. Vx is to the right and Vy is upward. Here it is the maximum height. After the maximum height, the object will move downward, and hence the vertical velocity is down, but still the horizontal velocity is to the right. Note here that the only velocity we have at the maximum height is Vx. Why? Because Vy is 0 at the maximum height. the vertical motion of this projectile is taken as an upward slope, whereas the horizontal projection is, or motion is, uniform motion. This is the release point, this is the landing point. The path followed is parabolic path, and it is symmetric because there is no air resistance. We have ignored it in our assumption. The direction of velocity changes because of Vy, and this is the path or the trajectory by which an oblique projectile follows. With no gravity, the projectile would follow the straight line path, dashed line. Neglecting air resistance, the following are equations of the incline projection. Let us see this first. With no gravity, the projectile will follow the straight line path means if there is no gravity, the object will move in this straight line path forever. But because of the presence of acceleration to gravity or gravitational force, the object will not move or follow this direction. Instead, it followed this curved or parabolic trajectory. The object followed this parabolic trajectory because of the presence of gravity. The horizontal and vertical motions of the oblique projectile can be analyzed as follows. The horizontal motion and vertical motion. The horizontal motion is uniform motion, and hence Vx is equal to x, or simply u cos theta. U is resolved into two components, Vx and Ui. Ui is u sin theta. Here Vx and Ux are equal because the motion is uniform, and acceleration to gravity is 9.8, but here there is no acceleration. Acceleration is 0 because air resistance is neglected. X is ux times t, or u cos theta times t, because ux is u cos theta, and range of the projectile becomes u cos theta times total time of flight. When we come to Vy is Ui minus gt, because do you know why minus? Because it is similar to that of upward slope, because the initial velocity of the projectile is in the upward direction. So this case is the vertical motion is taken as an upward slope. That is why we used Vy Ui minus gt, which is u sin theta minus gt, because Ui is u sin theta, or Ui squared is Ui squared minus 2j. We can substitute u sin theta in place of Ui. And for y, Uyt minus 1 over 2 gt squared, y minus, because it is similar to that of upward slope, u sin theta t minus 1 over 2 gt squared. These are equations of horizontal motion of oblique projectile, and these are vertical motions of oblique projectile. At any instant, the velocity of a projectile has two components, that is horizontal and vertical. The velocity of the projectile at any time t is given by the formula v squared vx squared vy squared, because they form an angle of 90 degrees with each other, and we use Pythagoras Theorem, where vx is equal to x, u cos theta, and vy is u sin theta minus gt, or ui minus t, because ui is resolved into or can be substituted by u sin theta. Example, oblique projection. This is the application. An object is thrown upward at an angle of 37 degrees to the horizontal with an initial velocity of 50 meters per second as shown in the figure below. Calculate the horizontal displacement x, vertical displacement y, horizontal velocity vx, and vertical displacement y, vertical velocity vy. This is the figure. It is thrown at an angle of 37 degrees with the horizontal. This is the initial velocity. The initial velocity has two components, ux and ui. And the values of y and that of x at any time t will be obtained by using equations of motion for oblique projection, and these are x is equal to x times t, u is u cos theta times t, which is 40t, y uit minus 1 over 2 gt squared, y is u sin theta u sine theta, u sine 50 times sine 37 0.6, which is 30 t minus 1 5 t square. Vx or ux is simply u cos 37 degree. Look, it is 40. U 50 times cos 37 0.8, which is 40. That's why x is equal to ux times t, which is 40t. Vy uy minus gt. Uy is 30 minus 10t. Do you know why 30? Because it is u sine theta. U sine theta is 50 times 0.6, which is 30. V is equal to square root of x square plus uy square. Times are 0, 1, 2, 3, 4, 5, and 6. X 0, because 40 times 0 is 0. 40 times 1, 40. Times 2, 80. Times 3, 220. Times 4, 160. Times 5, 200. Times 6, 240. So the horizontal motion is uniform motion. 0, 40, 80, 120, 160, 200, 240. Equal distance is covered with equal interval of time. Let us have a look at all this. 0, 0. In the first time, it has moved a distance of, in the first second, it has moved 40 meters. In the second time, it has moved 80 meters. At this 3 seconds, it has moved 120 meters. At the 4 seconds, it has moved 160 meters. At the 5 seconds, it has moved 200 meters. And at t is equal to 60 seconds, it has moved 240 meters. 240 meters. The gap is 40, and between 80 is 40. 80 and 120 is 40 meters. 120 and 160 is 40 meters, and so on. So equal distance is covered within equal interval of time. That is why we say the horizontal motion is uniform motion. When we come to the vertical motion, 30t minus 5t squared. Y is 30 times t minus 5t squared. When we substitute 0 in place of t, 30 times 0 is 0, minus 5 times 0 squared is 0. It is 0. 1, 30 times 1 is 30, minus 5 times 1 is 5, it is 25. 2, 30 times 2 is 60, and 5 times 2 squared is 20. 60 minus 20 is 40, and substitute the values of t, 3, 4, 5, and 6, and you will find these values. Look, 0, 25, 40, 35. Until 3 seconds, the height is increasing. But after 3 seconds, the height is decreasing. 40, 25, 0. Do you know why? It is similar to that of upward slope. It is the maximum height by which the projectile has reached. After that, its velocity becomes 0, vertical velocity becomes 0, look at here, and hence it returns back. That is why its displacement is decreasing. Vx or ux is 40, 40, 40, 40, 40, 40, 40, 40. Because uniform is a horizontal motion is uniform motion. This is motion with constant speed. When you see Vy, Vy is 30 minus 10t. When t is 0, 30 minus 0 is 30. When is 1, 30 minus 10 is 20. 2, 30 minus 20 is 10. And so on. It is 0. When it is 0, it indicates that it has reached at the maximum height. After this, the velocities are negative because the object is moving downward. And the resultant velocity at any time is given by 40 squared plus 30 squared is equal to 50. 30 squared, 40 squared, 1,600, 30 squared, 900. The sum of the two is 2,500. When it is taken out of square root, it is 50. 40 squared plus 20 squared, when it is in square root, it is 20 radical 5, and so on. When you see the vertical motion in this figure, look, it has raised a vertical displacement of 25 meters in 1 second, 40 meters in 2 seconds, and 45 meters in 3 seconds. But when it reaches at the maximum height, its velocity becomes 0, therefore it goes back. And after 4 seconds, the vertical displacement is 40 meters. After 5 seconds, it's 25 meters. And after 6 seconds, when it strikes the ground, the vertical displacement becomes 0. Derivation of time of ascent, total time of flight, maximum height, and range formulas or formulae. Time of ascent is the time taken by the projectile to reach to the maximum height. At the maximum height, the vertical velocity is 0. You have seen it. Hence, Vy sin theta minus gt means when Vy is 0, then the object reaches at the maximum height, and hence u sin theta minus g times Ta. T is converted into Ta because the object has reached at the maximum height. Because at the h max, the time is time of ascent. U sin theta is equal to g times Ta. Ta is u sin theta over g. This is the time of ascent. At the maximum height, the acceleration is not 0. Do you know why? Because at all points, acceleration to gravity is 9.8 meters per second square. Whether it is at the maximum height or at other points, the only acceleration we have is acceleration to gravity, and its value is 9.8 meters per second square. The maximum height. Maximum height is the maximum vertical displacement moved by a projectile. It is the highest point a projectile reaches during its flight. Look, it has moved a distance of 25 meters, 40 meters, 45 meters, 40 meters, and 25 meters. From all these vertical displacements, the maximum displacement attained by the projectile is 45 meters, and Y3 is known to be the maximum height. H max is u sin theta times time of ascent minus 1 over 2 square. Why? Because when the vertical displacement is h max, the time is converted to time of ascent. Time of ascent is u sin theta over g. Substitute u sin theta over g in place of the a, and the result of the is h max u sin theta times u sin theta over g minus 1 over 2g u sin theta over g square. H max is finally u square sin square theta over 2g, because u times u squared, sin theta times sin theta, sin square theta over g minus 1 over 2g times u squared, u sin theta square means u square sin square theta over g square. 1g is cancelled by 1g, so what's left is u square sin square theta over g minus 1 over 2 u square sin square theta over g. So the result you obtain is 1 over 2 u square sin square theta over 2g. Or from Vy squared is equal to y squared minus 2gh, we get 0. Vy is 0, y squared minus 2g times h max. When Vy is 0, h becomes h max, because Vy is 0 at h max. So solve for h max. H max is equal to ui squared over 2g. Ui is u sin theta, so u squared sin square theta over 2g is the maximum height attained by a projectile. Note that maximum height can also be symbolized by y max other than h max, because the vertical displacement can be represented by either y or total time of flight is the time taken by a projectile to return to its original position. It is the sum of time of ascent and time of descent, or it is the two times either time of ascent or time of descent. The time taken by a projectile to reach to the maximum height from the release point is known as time of ascent, and the time taken by a projectile to descend from the maximum height and reach to the ground is known as time of descent. The two are equal if the trajectory is symmetric. Time of ascent and time of descent becomes equal only if the trajectory is symmetric. The trajectory becomes symmetric if the gravitational acceleration is constant. We assume the gravitational acceleration to be constant in case of projectile motion. Hence, the trajectory is symmetric. As a result, time of ascent and time of descent have equal value. Therefore, total time of ascent, the total time of flight is time of ascent plus time of descent, which is 2 times time of ascent or 2 times time of descent. Time of ascent is u sin theta over g, so it is 2 times u sin theta over g. Total time of flight can be calculated as this. Let us see range. Range is the maximum horizontal displacement moved by a projectile. It is the horizontal distance from the point of bounce until the projectile returns to the surface. Let us see the previous figure. Look, this is the point of projection and this is the landing point. The maximum horizontal displacement or range here is 240 meters. X1 is 40, X2 is 80, X3 is 120, X4 is 160, X5 is 200, and X6 is 240 meters. The maximum horizontal displacement is 240 meters, and we call it range. So, range is equal to ux times total time or vx times total time, because ux and vx are equal, and ux or vx is u cos theta times total time. We can substitute total time by u sin theta over g from this equation. So range becomes u cos theta times 2u sin theta over g. 2u sin theta over g is equal to total time. It becomes 2u square, u times u is u square, 2 is here, sin theta times cos theta over g. R is therefore u square sin theta over g. Do you know why? Because from trigonometry we have the relation sin theta plus theta, or theta plus theta means 2 theta. Sin theta is 2 times sin theta cos theta. If sin alpha and beta are added, sin alpha times cos beta plus cos alpha times sin beta. So sin theta means 2 times sin theta cos theta. We can substitute 2 times sin theta cos theta by sin theta. Therefore, u square times sin theta over g. There are 2 angles of projection for the same range, that is theta and 90 minus theta. Thus, the ranges of 2 complementary projection angles are equal. Do you know what it means? 37 degree and 37 degree and 53 degree are complementary angles. Their sum is 90 degree. Sin 37 degrees 0.6. Cos 53 degrees 0.6, the same thing. So if we use 37 degree and 53 degree, it is the same. Let us do an example. Calculating time of ascent, maximum height, total time of flight, and range. An object is thrown upward at an angle of 37 degrees to the horizontal with an initial velocity of 50 meters per second. Calculate the time of ascent, maximum height, total time of flight, and range. This example is similar with the example that I gave you in oblique projection. Look at the previous example. The angle of projection is 37 degrees and the initial velocity is 50 meters per second. The only difference is the quantities that we are going to find. Let us do this problem. Time of ascent, maximum height, total time of flight, and range are quantities to be calculated. This is the solution. Ux is u cos 37 degree, u is 50 times cos 37 is 0.8, which is 40 meters per second. Ui is u times sin 37, ui which is 50 u times 0.6 sin 37, it is 30, G is 10 meters per second square. These are the given quantities. The required quantities are for a time of ascent. Note that at time of ascent, the object reaches the maximum height so that Vy is 0. It is vertical motion. If it is vertical motion, we can use equations of motion with uniform acceleration or SWAT equations. As a result, we can find the right formula by identifying the missed quantity. Look, Ui is given, G is given, and time of ascent is given and required, and Vy is already known. The missed quantity is y. If y is missed, Vy minus dt, because the object is thrown at an angle in the upward direction, and hence the vertical motion is similar to upward Ui minus dt. Ui is already calculated, 30 minus 10ta. Ui is 0 at time of ascent. Time of ascent is 30 minus over 10, which is 3 seconds. Hmax is required. At Hmax, Ui is 0. Ui and G are given. The missed quantity is T. When T is missed, the SWAT equation that we choose is Vy squared is equal to Ui squared minus 2Ui. Vy is 0. Ui squared is 30 squared minus 20 Hmax. Hmax is 30 squared over 20, which is 45 meters. The third one is total time of flight. Total time of flight, since the object is thrown from the ground and it returns back to the ground, y is 0 because it has reached at its initial point. So the missed quantity is Vy. If Vy is missed, the formula is y Uyt minus 1 over 2gt squared. Y is 0. T becomes total time when y becomes 0, 30 times t minus 5t squared. Solving for t gives 30 over 5, which is 60 seconds. D is range. When range is not a uniformly accelerated motion, because it is not a vertical motion, it is a horizontal motion. Hence, range is equal to ux times total time. Ux is already known, which is 40 meters per second, and total time is calculated in the vertical motion of the projectile, 6 seconds, and the range becomes 240 meters. Thank you very much.